In this video we will be learning on single fixed rotation gate. We will be doing the coding on Google Colab. Like we did in the previous video, we will be starting with installation with Blueqat. Type the code !pip install Blueqat in order to install Blueqat. Let us do it in Google Colab. Type the code shown earlier, and click on the play button. Blueqat will be installed afterward. Now we will learn about implementation of gates. HGate, XGate, YGate, ZGate, HGate, SGate, S plus gate, TGate, T plus gate can be implemented by the following. Now we will see about HGate. Here we use HGate, and if we run this code we will get the output as 0. Let us confirm this by doing it in Google Colab. Type the code that was shown earlier. Now click on play button. The output is 0. Next we will see about XGate. And here we use XGate. If we run this code then we will get the output as 1. Let us confirm this by trying it in Google Colab. Type the code that was shown earlier. Click on play button, and the output is 1. Now we will see about YGate. And here we use YGate. If we run this code then we will get output as 1, which is same as XGate that was shown earlier. Now we will see about ZGate. As you can see here we use ZGate. If we run this code then we will get output as 0, which is same as HGate that was shown in the beginning. Now we will see about HGate, and here we use HGate. If we run this code then we will get output as 1 and 0. Let us try it in Google Colab. Type the code that was shown earlier. Now click on play button, and as you can see the output is 1 and 0. Now we will see about SGate. And here we use SGate. If we run this code then we will get output as 0. And here we use SDGate as we have shown in the table of implementation of the gates. If we run this code then we will get output as 0. Now we will see about TGate. And here we use TGate. If we run this code then we will get output as 0, just like the output of earlier gates. And here we use TDGate. If we run this code then we will get output as 0. X, Y, Z gates. The matrix of these gates are XGate corresponds to the classic NOT gate, which replaces 0 and 1. ZGate can change sign only when qubit is 1. HGate. This gate is necessary for superposition of quantum states. This is the matrix of HGate. As you can see, we converted 0, 1 into superpositions, respectively. This is also a very important gate. It is called Hadamard gate. These are the matrix of the gates. The state vector changes, but the observed values do not change. Such a complex part is called a phase. It is called phase gate.